Okay. So, uh, are you able to see the slide? Hello? Hello? Are you able to see the slide?
Yes, we are able to see the sign.
Okay. So, so there are a set of data required before beginning the calculations for mixed design. Okay, so we will discuss it one by one and try to figure out how to decide on the site. So, in order to achieve desired concrete mix, a variety of data are required because strength of concrete depends on various factors in which concrete is being made and transported and placed, okay, and cured also. So it is not only the mixed design ratio that is governing the strength, but also these conditions in which it is being made and utilized. Okay, so concrete mix design depends on a variety of factors such as obviously grade of concrete, then exposure conditions, and use of chemical admixtures are there or not, and uh, conditions like curing conditions, etc. Okay, so let us discuss about how to fix and how to figure out what are the conditions which we need to consider. So I've made a list so that we can concentrate the factors one by one. So first we need to figure out what grade of concrete we need. Obviously, if we need M30, then we design for M30, and if we need M45, then we can go it about that. So first step in mixed design is to fix what grade of concrete we need. Number one. Number two, type or grade of cement. So if we need to find out what type of cement we are going to use in concrete. There are two types. One is PPC and PSC. PPC is Portland Pozzolana cement, and PSC is Portland slag cement. So Portland slag cement is particularly useful in case of places where high amount of sulfate present in the soil. So it is particularly useful for sodic lands, etc. But if such things are not there, generally PPC is good enough. And another type of cement is known as OPC, ordinary Portland cement. But nowadays, it is less in use because of its comparatively higher cost and lower positive features. Okay, so PPC displays a lot of positive features as compared to OPC. Third point is we need to the factor is maximum nominal size of aggregate. See, because in mixed design, it is a consideration of size of aggregate also in order to fix workability and strength. So we need to find out what type of aggregate size is going to be used in actual site conditions. Based on that, we should fix the maximum nominal size of aggregate. Fourth factor which is important is exposure conditions. See, exposure conditions are given in table 3 and table 5 of IS 456. And if you have IS 456, then I must recommend then you please open it. In this table, the exposure condition is defined as mild, moderate, severe, very severe, extreme. So minimum cement content and minimum cementitious content materials and maximum water cement ratio will be adopted and checked based on this exposure condition. And particularly exposure conditions are very much important while we design the mix design, because based on site conditions where concrete is going to be used, designer needs to select the exposure condition. Okay, so are you aware about the exposure conditions, how, what are that, and how it is set, it is being selected? Hello.
Hello.
Hello. Do you know what exposure condition means and how it is being selected? Okay,
It's
let
depending
me.
upon the one has to figure out.
Sorry,
Depending on the project, one has to figure out the exposure conditions.
just 1 minute. Just 1 minute. Let me. Okay, just 1 minute. Let me check the.
Hello.
Ji, hello. Let me show you what the table number 5 in just 1 minute. This is table. Okay. See, are you able to see the this table number 3? Just 1 minute. It is. Okay. Can you see the table?
Yes, we can see.
Hello.
We can see the table.
Okay, okay, okay. Please.
Now
See,
it is gone. The
in
table is
IS
not visible.
456, table is not visible.
Now it is visible. Visible. Visible.
Okay, okay. See, the first exposure condition, that is called mild. Mild means it is defined as concrete surface protected against weather or aggressive conditions, except those situated in the coastal area. Okay, so consider the environmental conditions as of Lucknow. So it is not a coastal area, and it is if your concrete surface is protected against aggressive weather. Means suppose you are using concrete for interior parts of the building, like interior columns, interior walls, etc. So it may be considered as a mild exposure. Okay, so it will not be exposed to the summer heat. It will not be exposed to the rainfall, etc. So it will be considered as a mild exposure, but considered as a moderate condition. So concrete surface sheltered from severe rain or freezing. Okay, so we are also does not have freezing conditions here. Concrete exposed to condensation and rain. Okay, so this is the condition we have here in Lucknow. Concrete is continuously underwater, so this is not the case here. Concrete in contact or buried under non-aggressive soil or groundwater. So this may be a case of Lucknow. And a concrete surface sheltered from saturated salt air in coastal area. So this is not the condition. So in moderate condition set, we are basically having this criteria: concrete exposed to condensation and rain, and concrete is in contact or buried under non-aggressive soil. Okay, so we have non-aggressive soil in Lucknow, and Lucknow does receive rainfall. So for the part of the building which is exposed to the atmosphere atmosphere directly, direct sunlight and direct rainfall, and for the parts where concrete is in touch with soil, so the foundation part, etc., may be considered as, up to plinth may be considered as moderate exposure condition. Okay, so it is quite safe to assume moderate conditions for Lucknow region. Okay, and you can read out for what severe means and very severe and extreme conditions are. Okay, so based on the site conditions, we can choose what type of exposure condition should be selected. Next point which is important is workability required. So you need to decide how much workability you need, and it depends on the placing conditions basically. Ranges vary from low to very high. So if you are designing the concrete mix for pavements, so mostly it will be, if it is a roller compacted pavement, then very low permeability is required. And if you are using concrete for piling and for casting thin walls, like thin shear wall, etc., very high reinforced column, then it is advisable for very high workability for the design consideration. Okay, so based on placing conditions, we can alter the workability required. It affects the ratio of fines to coarse and water also. Okay, now next factor is transportation time. See, if we are producing the concrete at the site, and or very near to the site, it means there is a very little time gap is there between production of concrete and its final placement where it is intended to be. So, so transportation time is quite less. Okay. So when transportation time is quite less, then you do not need any retarders for concrete mix. And if your concrete is coming from a distance, then you need a sufficiently good amount of transportation time. Mostly it is nearly 2 hours to 2.5 hours, and you need to use super plasticizers, which is also coming mixed with retarders. Okay, so based on the transportation time, we can choose the doses of the super plasticizers, what the dose is required. Okay, now next factor which is important here is method of placing. So if you are most common is chute placement or pumping. So if you are using concrete at the ground level or below ground level, then chute may be useful, and you can directly pour the concrete using a chute. In this case, you do not need much treatment, But if you are pumping the concrete, you need to be very careful about its grading, so that pumping can be done. Okay. So for pumping, a workability range of 75 to 100 is quite suitable. But for shoot, concrete of low workability can also be placed. Okay. Now, degree of site control. It is a very important factor again, degree of site control. So if it regulates the standard deviation, as we have discussed yesterday, sorry, day before yesterday, that if your work site quality control situations at the site are as per standard, then it may be considered as good, and you can take the recommended uh, standard deviation which is giving in the code. But if it is not there, it is somewhat less, then it will be considered as a fair condition, and you need to increase a standard deviation by 1 plus 1 in the recommended table. Okay. Next factor which is need to be considered is type and shape of coarse aggregate. So if it is angular crushed, rounded, semi-rounded, etc., then it affects the workability and water requirement. So we need to figure out what type of coarse aggregate we are going to use for concrete mix design. Okay, these data you need to collect before proposing a mix design. Uh, Next factor is type of fine aggregate. So nowadays, natural and stone crushed aggregates are commonly used. Earlier, natural fine aggregate is most common here in Lucknow region. But nowadays, because of the cost and environmental concerns, stone dust is also highly utilized. So, in case of stone dust, it does affect the workability, and because of quite rough in nature, is when we are using stone dust as a fine aggregate, it affects the workability. Okay, so we need to consider it. Maximum cement content. See, as per the shrinkage regulatory criteria of IS 456, we need to limit the use of cementitious material by 450 kg per meter cube. So 450 kg per meter cube is the maximum cement content which is allowed by IS 456. Because beyond that, because of the high cement content, there is a large shrinkage effect is visible, and due to large shrinkage, cracks are uh, uh, cracks are there in the concrete when it is set, so it is not as advisable so to go beyond maximum cement content of as per criteria of IS 456. Now, chemical admixture. So, are you going to use it or not use it? And if you are going to use it, what is the dose? You need to figure it out. Okay, because correction of water requirement will be done based on your dosage and type of admixture. Now, next factor which is important is mineral admixture. Mineral admixture are used or not, it is again a point of concern, because some mineral admixtures will have cementitious property and does affect the actual percentage of cement which is being used. So if it is a class C fly ash, it will be a cementitious property. It will have a cementitious property, and it affects the mixed design choice. Okay. Any other specific requirement are there, then you need to consider it also. Suppose you want early strength. So early age strength, if it is required, so it regulates the use of special chemicals which supports in uh, early age strength requirement, and suppose any other specific requirement, such as if you want to create any color for the concrete, then you need to choose the pigment. If you want a the air entrainment, then you need to select different kind of chemicals and other admixtures, etc. Okay, so these are some factors which we need to sorry, which we need to figure it out before proceeding for the mix design. Okay, you understand? Do you have any question, or shall I go further?
Yes, sir. Move further.
Okay. So let us take a concrete mix proportioning of our ordinary strength concrete, which is valid up to M65. And in this is a most commonly used mix proportion in variety of projects. In Lucknow Metro, the maximum grade of concrete which is being used is M60. And in upcoming project of Kanpur and Agra Metro, it is also M60. So it is highly used mix design, and up to M65 the mix design procedure is same. So let us take a mix proportioning for M40 grade of concrete. Now, based on the our requirement, we just take up a data table which we just discussed. So, grade of concrete is selected as M40, and type of cement is PPC, conforming to IS 1489 Part 1, and the maximum nominal size of aggregate is selected as 20 mm, because this is 20 mm is the most common size for RCC work. Uh, Exposure condition is taken as severe, just for the case. But if you want to take it moderate, then you can also take it moderate. Now, next point is workability. So 75 mm slump is selected. Transportation time not required. No additional time is required. So it will be considered as it is very near to the site production, and no retarder is added. Method of placing is shoot, and degree of site control is good. Type and shape of aggregate is considered as angular. Type of fine aggregate is natural fine aggregate. Maximum cement content is already 450 kg. Chemical admixture which is being used is super plasticizer, and mineral admixture is not used, or any other specification is not mentioned here. So there are some other data which is being used for the calculation purpose. Is cement is again the PPC, and the specific gravity of cement is taken as 2.88 kilogram gram per centimeter cube. You can take the specific gravity of cement based on the manufacturer certificate. Almost all the cement lies near to that, but for if in actual mixed design procedure, you can directly ask the client what type of what cement you are going to use it, and the manufacturer certificate, by reading manufacturer certificate, you can directly find out what is the specific gravity of cement. You can find out this specific gravity of cement in the laboratory also, if it is not available. Chemical admixture is again super plasticizer, it is already mentioned. A specific gravity of coarse aggregate is taken as 2.74, and it is as SSD condition. SSD means saturated surface dried condition. Okay. So, are you aware about it? Saturated surface dried condition? Okay, actually, all the mixed design are conducted based on assuming that the aggregate is saturated and surface dried condition. So basically, it is what that you know that every aggregate is having some porosity, and it intends to suck up some water from the mixed concrete mix, which is otherwise available for the hydration of cement. So we do not basically want to disturb the water cement ratio. So we consider the specific gravity of coarse aggregate and fine aggregate at saturated surface dried condition. So saturated means it is fully saturated in water. Whatever water uh, it is needed, it is already being provided with. Okay, so it will not take any water from the concrete mix, which is provided for the hydration of cement. Now, surface dried means there should not be any dripping of water. So I think you all have seen the coarse sand in the rainy season. If you take a wet sand in your hand, it will your hand will get wet. Okay, so some water is being entrapped between the particles of the aggregate, and you it is freely available. So when you mix such type of aggregate which is having more than which is having entrapped water between its particle, so it water cement ratio is basically disturbed, and you actual water which is present in the mix is quite higher than the design value. So, as per the design criteria, we assume that there will not be any sucking up of water from the mix, and there will not be any extra supply of water by the aggregate. Okay, but in actual condition, this is not the case. Okay, so, in actual condition, although aggregate is we are trying to protect the aggregate from direct rain. So, in actual condition, either moisture is excess in access to the saturation condition, or some moist if it is in dry state, so it will not be at fully saturated condition. So there will be some loss of water from the mix, or there must be some supply of water from the aggregate. So what we need to do, we need to apply moisture correction in base on real time basis. Okay, so hello, are you listening to me? हेलो।
जी सर, जी सर।
जी जी, समझ में आया सैचुरेटेड सरफेस डाइट कंडीशन क्या होती है?
जी जी।
Yes, yes.
ओके, सो एक्चुअल कंडीशन में जब अगर एग्रीगेट ड्राई होता है, मोस्टली ड्राई कंडीशन अगर प्रिवेल कर रही है, सूखा हुआ एग्रीगेट है, तो वो पानी तो जरूर लेगा ही लेगा। तो क्या करते हैं कि हमें पता है कि एग्रीगेट कितने परसेंट ऑफ मॉइस्चर पे सैचुरेट हो जाता है। तो डेली बेसिस पे इट इज रिकमेंडेड बाय द कोड दैट कोर्स एग्रीगेट का मॉइस्चर कंटेंट हर दिन मेजर किया जाएगा, और फाइन एग्रीगेट का मॉइस्चर कंटेंट दिन में 2 बार मेजर किया जाएगा, और इसी बेसिस पे मॉइस्चर करेक्शन अप्लाई किया जाता है मिक्स डिजाइन में। अगर ज्यादा सैचुरेशन है, पानी ज्यादा अवेलेबल है, तो टोटल जो वाटर आप मिलाने जा रहे हैं उसको रिड्यूस कर दिया जाएगा, और अगर पानी कम है तो जितना मॉइस्चर अवेलेबल होगा उसका बैलेंस पानी एक्स्ट्रा ऐड कर दिया जाएगा, ठीक है। Now specific gravity of chemical admixture is taken as 1.145. See, this is the data which is needed for the moisture correction. See, water absorption coarse aggregate limit is 0.5 and water absorption for fine aggregate is 1%. So fine aggregate can take water up to 1% of its weight and coarse aggregate will take water up to 0.5% of its weight. This is the maximum limit, okay? This is the virtue of the material. And actual moisture content present in the coarse aggregate is considered as 0. So it is considered as that coarse aggregate is absolutely dry and fine aggregate is also absolutely dry. Just assumed for the trial mix design. Okay. Otherwise, if it is non-zero, you can adjust it based on balance percentage. So, by conducting sieve analysis of coarse aggregate, it is found to be as per requirement of IS383. And sieve analysis of fine aggregate, it is found that it is of lying in zone 2 as per IS383. Now, to begin with mixed design, first we need to find out what is the target mean strength we should be taking up. So these are two formulas, and based on this formula, whatever is coming up higher, we are going to use it. So actually, we are not having any real-time data of standard deviation. So we are going to select standard deviation from the table. So from the table, we can find out that standard deviation for M45 is 5 Newton per mm square. And from table 1, X is given as 6.5. So based on two formulas, we calculate it and find out that this is giving that target mean strength is giving as 48.25 and this is given as 46.5. So the higher will be, higher is this 48.25. So we take this value as a mixed design calculation, 48.25. Okay. So in order to have for M45 at site, we are going to use we are targeting this strength so that we can actually get M45 on the site. Okay. Now next point is air content. In absence of actual site data, the approximate, if you have actual site data of 5 sites, okay, then you can decide the air content in concrete as per actual data. But if it is not there, you can take 1% for 20 mm nominal maximum size of aggregate. Okay, if it is a non-air entrained concrete, which is normal concrete, means non-air entrained concrete, you can take 1% value for M20 mm nominal aggregate. So it is given in the table also that for 20 mm aggregate you can take air content is 1%. Now next point is deciding water cement ratio. See, so from figure 1, the free water cement ratio required for target strength of 48.25 is 0.36 for OPC 43 grade curve. Okay. For PPC, strength corresponding to OPC 43 grade curve is assumed for the trial. Okay. Now, how to read this? See the note. Curve is given for OPC. Okay, 33, 43, and 53. But we are using basically PPC. So notes, see the notes. In the absence of data of actual 28-day compressive strength of cement, curve 1 to 3 may be used for 33, 43, and 53. And second, while using PPC, the appropriate curve as actual strength may be utilized in the absence of actual 28-day compressive strength, curve 2 may be utilized. Okay. So if it is available that the PPC which you are going to use is so much of actual strength is given at 28 day, then you can read it based on that actual strength. Okay. But if it is not given, you can read curve number 2. Okay, middle curve for OPC 43. So the grade of target strength is nearly how much? 48.25. So it is 48.25 nearly. And by reading the curve number 2, what we have found? This ratio, nearly 0.36. Okay. So 0.36 is adopted. Now, now come to the checking of water content based on exposure condition. Okay. So this is the exposure condition table 5 of IS 456, and see, we have selected the severe exposure condition. Okay. So for severe exposure condition, and we are basically use it for reinforced concrete, then what is the maximum water cement ratio? 45. Okay. So the water cement ratio which you have selected is should be less than this. So we have find out 0.36, so it is less than 0.45, hence it is okay. Okay. Minimum grade of concrete is M30, so we are designing for M45, so it is also fine. And it is giving that again a data of minimum cement content. So we will be looking it in next slide. Now, from table 4, water content is how much? Nominal maximum size of aggregate is 20 mm. So water content per cubic meter of concrete for nominal maximum size of aggregate. So water content is being fixed first. So for 20 mm aggregate, it is limited to how much? 186 kilogram. See, again, so for mixed design, what we need? Water, we need cement, we need coarse aggregate, and plus fine aggregate. Okay, plus and admixtures. Okay, admixture. So first we are going to decide amount of water. So for 20 mm aggregate, amount of water will be, for 1 meter cube, amount of water will be 186 kg or 186 liters. Now here is a catch. This water is given for the slump of 50 mm slump only. Okay, are you listening to me? Please listen carefully, otherwise it will be a little bit difficult. Okay.
Yes, sir.
Now, the actual slump required in the question is 75 mm slump. So we are basically requiring 25 mm more. ठीक है? तो क्या करेंगे? See, देखिए इन्होंने क्या कहा? The required water content may be increased or decreased by about 3% for each increase or decrease of 25 mm slump, or may be established by trial. So basically we are designing a trial mix, so we do not have the trial data. So what we are doing, हमें 25 mm slump increase करना है, तो हम 3% पानी increase कर देंगे. तो यहाँ पे देखिए क्या किया हम लोगों ने. 186 is given from here, and we just increase 3% of water and added here. So total water which is required is 191.58 kg. Okay. Now, as we know that super plasticizers are used to reduce the water requirement, and actual data may be utilized by the manufacturer that whatever super plasticizer you are going to use, how much water it can reduce. Okay, So, but for trial, IS code is taken as 23% of water reduction for 1% of doses. So we adopt this trial value, and 23% of water is reduced, assuming that 1% dosing is there. So we just reduce 23% and by multiplying it 0.77, basically 23% reduction, and our water content comes out to be 148 kg. Okay, so now we have fixed that water is 148 kg for our mix design. Okay, so first point is completed. Now, based on this water, we are going to figure out how much cement we need. Now, as we have selected that water cement ratio will be 0.36, so by knowing water, we just find out the cement. So divided by 0.36 and we find out the cement content is how much? 411.11. So approximately 412 kg is considered. Now 412 kg cement should be checked under two criteria. First criteria is it should not be more than 450 kg. Okay, so it is okay. It is less than 450 kg for shrinkage criteria. Shrinkage criteria. Okay, and it should not be less than this value, 320 kg for severe condition and for reinforced concrete. So it should be more than 320 kg in order to ensure the durability criteria. This is called durability criteria. Okay, ये याद रखिएगा, durability criteria. Okay, 300 minimum cement content is to be ensured to ensure durability, and maximum cement content should be ensured, limit should be ensured considering shrinkage criteria. Okay, so our adopted cement, the calculation comes out to be 412, which is between it, so it is fine. Okay, so two things have been decided: 148 kg of water and 412 kg of cement. Now what is left? 1% dose of plasticizer is also decided. So that will be 1% of cement. So it will be nearly 4.12 kg. No, 4.12. Actually, it is having 1.145 specific gravity. No? So 4.12. How much is it? 4.12 into 1.145. It is nearly comes out to be 4.7 kg. Okay. So we have find out three things. Now the aggregate part. It is a little bit tricky, so please see carefully. Now from table 5, total volume of coarse aggregate per unit volume of total aggregate for different zones of fine aggregate of water cementitious material ratio for 0.5. See what it is given. If it is given, if water cement ratio is 0.5, then code is giving the ratio of coarse aggregate to fine aggregate. Okay, this is the what? Total aggregate. Okay, so it is giving the ratio for what the water cement ratio 0.5. So let us find out first this. So we have maximum nominal size aggregate of 20 mm. So for zone 2 we are using zone 2 sand, and the ratio will be 0.62. It means 62% will be coarse aggregate, and 38% will be fine aggregate. Okay, यहां तक ठीक है? हेलो,
जी सर जी।
ठीक है, हाँ, यहां तक अब समझ में आ गया। 0.5 वाटर सीमेंट रेशियो, M20 सॉरी 20 mm नॉमिनल साइज एग्रीगेट और जोन 2 की सैंड, इसके लिए 62 और 38 का रेशियो हमें मिल गया। अब हमारा वाटर सीमेंट रेशियो 0.5 तो है नहीं, हमारा वाटर सीमेंट रेशियो कितना है? 0.36। तो हमें इसके हिसाब से इसको एडजस्ट करना पड़ेगा। ठीक है, कैसे एडजस्टमेंट करेंगे? इसके लिए देखिए क्लॉज 551 में डिफाइन किया है। टोटल एग्रीगेट इज इंक्रीज्ड at the rate of 0.01 for every decrease in water cement ratio by 0.05. ओके, तो देखिए हमारा वाटर सीमेंट रेशियो कितना डिक्रीज किया है? 0.14। 0.5 में से 0.36 माइनस कर दिया, 0.14, यानी 0.01 का 14 टाइम्स। ओके, अब हमें कितना वाटर सीमेंटेशन ये चेंज करना है? 0.05। तो क्या करेंगे हम? सिंपल, ये आपने 14 टाइम्स एंड डिवाइडेड बाय 0.05। सो कितना चेंज करना है? 0.028। तो टोटल जो एग्रीगेट होगा, कोर्स एग्रीगेट, वो इतना इंक्रीज हो जाएगा, इतना 0.028। देखिए क्या करेंगे, पहले 62% था, अब कितना हो जाएगा? 62 प्लस 0.028 यानी 64.8, यानी कि अब कोर्स एग्रीगेट हो जाएगा 64.8%, और टोटल फाइन एग्रीगेट कितना हो जाएगा? 1 में से माइनस कर दिया तो 35.2% फाइन एग्रीगेट हो जाएगा। ओके, ये एडजस्टमेंट समझ में आया आपको? हेलो,
Yes.
ये एडजस्टमेंट समझ में आ गया?
Yes, yes.
Okay. Now you know about the ratio. Now what we are going to do? We are going to find out the total amount of aggregate, and it will be divided in this ratio. Okay. Now the first total volume of concrete will be 1 meter cube. Okay, and air is given as 1%. Okay. So volume of cement will be how much? Mass of cement divided by specific gravity of cement, and divided by 1000. Okay, so 412 divided by 2.88 divided by 1000, and your uh, total volume of cement will be 0.143 meter cube. ठीक है? Second, volume of water, simple, because specific gravity of water is 1, considered as 1. So total 148 kg of water we are going to use it. So volume of water will be 0.148 meter cube. Okay. Now volume of plasticizer, 1% of the cementitious material. So 4.12 kg. No. This is calculation error. Okay, because the specific gravity is 1.145. 1% by weight है. Okay, sorry. Okay, this is right. 1% of not by volume है, it is 1% by weight. So it is right, 4.12 kg. Now 4.12 kg will be converted into the volume by dividing up the specific gravity. Total volume comes out to be 0.0036 meter cube. Okay. Now, as we know, total volume will be 1 meter cube. So it will have what? Water, cement, air, and plasticizer. Okay, plus aggregate. So we know all four. So by subtracting from this 1 meter cube, we will find the volume of aggregate. So volume of aggregate comes out to be how much? This 0.695 meter cube. Okay. Now we know that ratio of coarse aggregate is 64.8% and its specific gravity is 2.74. So just multiply it by 1000. So convert it from the meter cube to kg, 2.74 into 1000. So total weight of aggregate is 1234 kg. And the total mass of fine aggregate will be total volume 35.2%, 2.65 specific gravity, and 1000. So 648 kg of fine aggregate should be used. Okay. Now, so trial number one comes out to be cement 412 kg, water 148 kg, fine aggregate 648 kg, coarse aggregate 1234 kg, chemical admixture 4.12 kg, and water cement ratio is 0.36. Now see, the problem is aggregate shall be used in saturated surface dried condition. If otherwise, when computing the requirement of mixing water, allowance shall be made for free surface moisture contributed by the fine and coarse aggregate. Okay. So let us okay. So what happens? Because in question it is given actual moisture is 0% in both coarse and fine. So and also given that coarse aggregate can soak up to 0.5% of water and fine aggregate will soak 1% of water. So this water will be soaked up by aggregate. So we need to adjust the water. Okay. So that this ratio shall be maintained. Now how to do that? See, for fine aggregate. Mass of fine aggregate in SSD condition is 648. Water absorption is given as 1%. So this is the correction. Okay, 1 by 100. So how much it comes out to be? 641.58 kg, means 642 kg of fine aggregate is there. And coarse aggregate water absorption is given as 0.5. So total is 1228 kg per meter cube of coarse aggregate. Okay. Now these values are reduced, so rest water should be increased. So earlier coarse aggregate is 1234 kg and now it is 1228. So 6 kg of weight is reduced, taken up by the water, and here earlier weight is 648 kg, now it is 642. So 6 kg of water is taken by the fine aggregate. Total 12 kg of water must be increased in suggested water. So water will be 160 kg per meter cube. Okay. Now the adjusted water cement ratio is cement 412, water 160 kg per meter cube, fine aggregate ये गलत लिख गए क्या था 642 1228 642 1228. Okay. Chemical admixture is 4.12 kg and free water cement ratio is 0.36. Okay, fine. Now there are some notes. It is important thing. Please note. The total mass of coarse aggregate shall be divided into two fractions of 10 to 20 to 10 mm and 10 to 44.75 mm in a suitable ratio to satisfy overall grading requirement of 20 mm maximum size aggregate as per table 5 of IS 383. So this total aggregate, coarse aggregate, which is comes out to be 1228, it shall satisfy the grading requirement of IS 383. Okay, so it shall have different fractions as recommended by the code. ऐसा नहीं हो कि सिंगल साइज एग्रीगेट नहीं होना चाहिए, ये कंक्रीट में रिकमेंडेड नहीं होता, अदरवाइज कंक्रीट जो होगी वो वाइडेड हो जाएगी. दूसरी बात, slump shall be measured at calculated water cement ratio shall be adjusted for achieving the required slump based on trial if required. So देखिए इसमें एक चीज बहुत जरूरी होती है कि 75 mm slump अगर आपको रिक्वायर्ड है और आपने मिक्स डिजाइन किया है, तो इस मिक्स डिजाइन को सिर्फ कर लेने से ही काम नहीं चलता है. जब आप ये मिक्स डिजाइन बना लेंगे तो एक ट्रायल मिक्स आपको बना के ये चेक करना पड़ेगा कि 75 mm स्लम्प आपका आ रहा है या नहीं. अगर नहीं आ रहा है तो आपको पानी थोड़ा एडजस्ट करना पड़ेगा या थोड़ा प्लास्टिसाइजर एडजस्ट करना पड़ेगा. ठीक है. अच्छा, थर्ड पॉइंट, while meeting durability requirement, two more trials having variation of plus minus 10% of water cement ratio in calculated mix shall be carried out, and a graph between three water cement ratios and their corresponding strengths shall be plotted to work out the mix proportion for given target strength or for field trials. See, जब आप एक मिक्स डिजाइन तैयार कर लेंगे और स्लम्प भी अचीव कर लेंगे, तब उसके बाद आपको क्या करना है, उसके बाद आपको प्लस 10% वाटर का एक मिक्स बनाना है और एक माइनस 10% वाटर का एक मिक्स बनाना है. ठीक है, यानी कि 0% एडजस्टमेंट, प्लस 10% वाटर, माइनस 10% वाटर, ये तीन आपको मिक्स बनाने पड़ेंगे और तीन मिक्स के बेसिस पे ये चेक करना पड़ेगा कि आपकी टारगेट स्ट्रेंथ अचीव हो रही है या नहीं. ठीक है, अगर अचीव हो रही है 0% पे तो बहुत अच्छी बात है, और अगर नहीं अचीव हो रही है तो आपको एडजस्टमेंट करने पड़ेंगे. ठीक है, ये तीन बातें बहुत जरूरी हैं, इनको हमेशा जहन में रखिएगा. पहला, टोटल एग्रीगेट आपने निकाल लिया, दैट इज फाइन, but it shall satisfy the grading requirement of IS 383. Number two, whatever mix design you have created, it should give your required slump. If it is not given that slump, you should adjust it. Now, third point, after adjusting the slump, you shall be, it is recommended to make plus 10% of water by increasing water cement ratio. And by decreasing 10 water cement ratio by 10%, you just made another mix and find out that what is target strength is there. So if you are so confirm your target strength based on these three trial mixes. Okay, so it means if you are doing rapid curing test, then you need at least 4 days to figure out you are designing the right mix design. Okay, and actually you if you have time, you should wait for 28 days and find out the result, actual result. But actually what happens, because it is a trial mix, you cannot wait for 28 days for every trial mix. So what happens, usually trial mix is being created and slump is checked, and a rapid curing test based rapid strength gain test will be conducted, and based on the result it will be interpreted that your mix is right or wrong. So but if it is comes out to be right, then it is again recommended that you should check this mix ratio at least once for 28 days strength, actual strength, because this is the only strength which you can believe. Okay, because of variety of factors, it may be possible that when you actually use at the site, it may give you something else. Okay. So this is the design mix calculation procedures and its interpretation of various items. And I hope you understand how mix design can be done. Is it any question?
No, sir.
So please go. Please download IS 10262 2019. It is available in on the net. Do you have it? It is freely available on the net. Not the verified copy, but also you can have it. Okay, and just go through it. Okay, I will share this PPT to your WhatsApp group, and please go through it. Okay, uh, at least do it once. Otherwise, you will be it is sometime it is get confused when you are actually going to perform it. Okay, so that's all for today.